Tonight we start talking about our new unit covering circles, and so hopefully a lot of what we're going to talk about tonight is a review. But a circle, by definition, is the set of all points that are equidistant from a single point known as the center. So if you picture someone standing in a particular spot and they're holding like a jump rope or something, for example, and someone is holding onto the other end of the jump rope and you pull it so that there's no slack in it, and then that person walked all the way around the one person standing in the middle, then the path of that person would create a circle. So the length of the jump rope is the exact length all the way around the person holding the jump rope in the middle. So you would create a circle. The length of that jump rope in that scenario would be known as the radius, or the distance from the center to any point on that circle. A diameter, most of us know, is the distance from one end of the circle through the center to the other end of the circle, also known as um, a radius plus another radius on the other side. So it's equal to twice the radius. Okay, so what might be new is what we call the standard equation of a circle. So we're going to talk about how we graph circles, and we're going to graph them from an equation, and the standard form of the equation looks like this, where H and K stand for the center coordinates of the circle, and the R stands for the radius, or the length of the radius of the circle. Okay, so to graph a circle from the standard equation, the first thing we're going to do is, from our equation, find the center point. Keeping in mind that the H in our equation is the x coordinate and the K is the y coordinate. So if we take a look at our example down here, we have a center that's at 0, -1, because there's nothing that we're subtracting from our x. So if you take a look, there is no h value. So that means that we are subtracting nothing. So the x coordinate would be 0, and the y coordinate would be -1, because in our original equation, we subtract our k value. And so the only way to change that subtraction to a plus is for that 1 to be negative, and we would subtract a negative, which would make a positive. So to graph that, we just graph the center point, which is at 0, -1. You put a point there, okay? And then you find the constant, which is the number all by itself right here. And the constant, sorry, I just want to make sure we understand, is 16. So our r squared equals 16. So to find the radius, we just need to take the square root of 16, which gives us 4. So from our center point, we're going to count up, down, left, and right, 4 points, the length of our radius, and then we're going to try to connect them as best we can, which you'll see is easier said than done. But there's our circle. Perfect. Okay. And we're also going to have to do the opposite, which is to take the graph of a circle and then write it in standard form. So the first thing we want to do is identify the coordinates of the center. So this center is at 2, 1, 2, 3. It's actually at -4. So that's just great. But this should be -4. Sorry about that. And you can find the length of the radius by counting from the center, either up, down, left, or right, if it goes to a point, an integral point we call it. Um, if it doesn't, then we have to use our distance formula, so picking our center and then any other point on the circle that we can count to, and then substituting that into the standard form. So we have x minus h. H is the x coordinate, so that's why I put the 2 there, plus y minus k, which again should be -4, so imagine this is a -4, equals our radius, which is the center to any point on the circle, is 3. So I plugged in a 3. And then the last step would be to just clean everything up. So if I have any double signs like I have here, if I have any zeros, which I do not in this case, and then squaring anything that I can, gives me x minus 2 squared plus y plus 3 squared because of the double negatives equals 3 squared, which is 9.